Welcome to Ask and Learn.
So continuing on with physical chemistry, the first thing we're focusing on here is our differential and integral equations. And so in part A, our differential balance on the total mass is dm dt, which is equal to dm I over dt, where mi in terms of the mass flow rate modified equation will be m dot equals m dot I. So we use the relation from our equation, that is d bracket density v over dt, and then we're able to solve for dv over dt, that is equal to vi flow rate. And then we can solve for the differential mole balance equation, Ca naught v dot negative k n a. So moving on, we have the steady state to take a look at now. So we substitute 0 for dna over dt in the following equation, that is dna dt is Ca naught v dot subtract kna. Substitute in 0 for this part, so we can solve for na is equal to Ca naught v dot over k. Therefore, the formula for the steady state value of na is Ca naught v dot over k. Part C. We're able to rearrange the following equation. dv dt is v dot for dv, to get dv is v dot dt, integrate within the limits v 0, t 0, get v is equal to v dot t. Therefore, the expression for vt is v equals v dot t. So following this, we can take a look at the expression for NAT. So we're rearranging a previous equation. So we have Ca is equal to Na over V, that is of interest. We have dt is equal to dna over Ca naught V dot negative kna, when we are rearranging for dt. And then we can integrate the above equation with specified limits within na and 0 and t and 0. So we can solve for na is equal to Ca naught V dot over k, 1 take away e negative kt. Then we can substitute the value of na from the above equation into the equation here. And this tells us that when the feed rate of A equals the reaction rate of A, then Na reaches a steady state. Whereas this is not actually possible in the real reactor because of the following reasons that we can discuss. So as calculated, V is equal to V dot T. So when T approaches infinity, the volume also approaches infinity. But in a real reactor, the volume is limited by the reactor volume. It will never be able to reach infinity. Also, the steady state can only be reached at T equals infinity, but in a real reactor, the reaction time is finite, so we would never be able to approach infinity for practical reasons. So we can calculate the limit value where we have limit CA is equal to limit CA naught 1 take away E negative KT over KT, and when we can have T approach infinity, we have NA equals CA naught V dot over K. Shows that NA is a finite quantity. And whereas if V approaches infinity, we can use CA is NA over V. And what this can do is prove that this equation equals 0. That's 1 over infinity equals 0.